Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Salahuddin bin Abdul Salam. So we are from Group 2. So today we are going to present our group project. So the project name that we propose is Intelligent Parking System. So I will be the first presenter for this group. Before I started my presentation, let me introduce you with our team members. So, our team's members consist with 4 people, which is led by the team leaders, that is Muhammad Nazran bin Abdul Asnis, and he was assisted by CO leader Nur Alia Antasha. And then for the project manager, it was me, Muhammad Salahuddin bin Abdul Salam, and also I was assisted by assistant project manager, which is Wubahan Raj, anak lelaki Partiban. So I will start first with the introduction. For the introduction of this project is this initiative aims to eliminate parking lot traffic jams, which is particularly at malls and other buildings, because we know that these two locations are the most crowded and always have full parking lots. So the advancement of this idea is having a display so the entire community can see if there is a parking available or not, as well as the data from the parking park that we can only access on our smartphones. Then for the next slide is a problem statement. So the problem statement of our project is, the first one is lack of real-time data on available parking space. For the second problem is increased traffic and emission due to drive circling for parking. Then the next one is environmental impact from heightened fuel consumption and emission. For the last part is ineffective space management in parking facilities. Then we move to the project aims. Our project aims is, the aim of this project is to develop an intelligent parking system using IoT or Internet of Things for humankind or society. Okay, then we move to the next part, which is the objective of this project. The first objective is to design an intelligent monitoring parking system, and the second is to develop an intelligent parking system with IoT-based monitoring. Then for the last part, which is the number 3, to verify the functionality and performance of the proposed system via experiment setup. So we have arrived at next topic, which is literature review. So for this topic, I will share about the difference between intelligent parking and basic parking. So in term of time savior, intelligent smart parking system, it has a real-time location and track the number of empty parking space. For basic parking system, the traditional parking is notorious with time-taking factors, and then a fuel and cost efficiency. For this term, for intelligent parking system, by using the system, drivers can save time and money on fuel by not wasting it by searching for a place to park their cars. Then, for the basic parking system, for fuel usage, it negatively impacted by basic parking, which further reduce cost effectiveness. So, the next term is greenhouse effect. These days, for intelligent parking system, it make it simple to reduce the amount of greenhouse gases in the atmosphere. So, for basic parking system, the greenhouse effect is greatly increased by basic parking because it take longer for automobile to park. It take a longer time for this for car to find their park. So the next is prevent extra traffic on the road. For the intelligent parking system, using this parking method or parking system, people can use their smartphone to look for and find a vacant parking space. While for the basic parking system, an inadequate parking system was the main factor attracting additional traffic to the areas. Then the last part is increase the overall parking spaces for the intelligent parking system. It might offer hassle-free, which is no jam on the traffic, and navigation, and it also offer the navigation or the most efficient path to the designated parking space. And then for the basic parking system, moving a car to any place and finding an empty space is usually a pain with basic parking system, and it takes a long of time to find an empty parking system. So this is all for the literature review.
System block diagram and explanation. Smart parking system using IoT project makes use of an Arduino Uno and non-MCU microcontroller. 3 parking spaces are allocated in the intelligence parking system using the IoT project. The IR sensor in this parking space monitoring system is controlled by an Arduino Uno and non-MCU V3 board. Module, servo motor, and the crystal display also. One of non-MCU integrated ESP8266, an electronic gadget that enables us to establish an internet connection inside. The smartphone and non-MCU V3 board are needed to connect to the hotspot network in order to obtain data for the research. Initially, a power bank is utilized to recharge the cord to the non-MCU V3 board by using a micro USB. The 3.0 voltage supplied by the non-MCU V3 board to the thermal imaging sensor. 2 servo motors are positioned at the entrance and exit of the car park respectively. Additionally, a sensor is positioned at the car park's entry and exit to count the number of parking spaces. The non-MCU V3 board moves the servo motor when it gets a signal from the IR sensor at the entry and exit. The available parking space will also be displayed on the web page at the same time. Automobiles will be permitted to enter if the total number of automobiles is less than 3 until it reaches the maximum amount, which is 3 cars. When the maximum number of cars is present in the parking lot, no more cars will be permitted to enter. The number of parking spaces that are available will be displayed on the LCD screen. One possible use for the web interface in a browser is as a monitoring system. System flowchart and explanation. An illustration of the steps in a system or a process is provided by a system flowchart. An intelligent parking system's flowchart would show the order of operations and interactions between various parts in order to accomplish the objective of effectively managing parking spaces. The process begins with the user approaching the smart parking system. To count the number of parking spaces, a sensor is placed at the entrance and exit of the parking lot. When the non-MCU V3 board receives a signal from the IR sensor at the entry and exit, it moves the servo motor. Simultaneously, the web page will display the available parking space. If there are fewer than 3 cars overall, they will be allowed entry until the maximum, which is 3 cars, is reached. No further automobiles will be allowed to enter the parking lot once the maximum number of cars is present. The LCD panel will show the quantity of parking spaces that are available. This is our project 3D layout. As you can see, first, intelligent parking 3D layout front view. Second is intelligent parking 3D layout top view. And lastly, intelligent parking 3D layout back view. Project circuit diagram and explanation. Electronic devices connected to components such as servo motor, LCD display, and IR sensors. IR sensors at the entrance and exit are attached to pin 8 and 4 of Arduino Uno respectively. Servo motors at the entrance and exit are attached to pin 13 and pin 3 of Arduino Uno respectively. The SDA of the LCD display is attached to the A4 pin of the Arduino Uno, while the SCL of the LCD display is attached to A5 pin of the Arduino Uno. Next, another IR sensors for the parking slot are attached to pin 7, 6, and 5 Arduino Uno, while the green LED indicates that the park is still available and is coupled to Arduino Uno pin 9. The red LED indicates that parking is already full and attached to pin 10 of Arduino Uno respectively. One node MCU was utilized in the Intelligent Parking System projects. TX and RX pin node MCU attached to pin TX and RX from Arduino Uno. On the other hand, node MCU can update the most recent informations on the homepage because node MCU has a Wi-Fi connection.
Hi everyone, my name is Ruben Raj. My metric number is DN220150. So for my presentation, for the slide, I gonna explain about result and discussion for our TDP project, which is Intelligent Parking System. So this slide represent the project hardware picture for our project, which is Intelligent Parking Sensor System. The upper picture shows we are not arranged it properly, but the sensors and the components all work properly, which is LCD display, and then the power supply, Arduino Uno, Node MCU all work properly. And the below picture shows that we arrange it properly according to the slot of parking, and then we arrange it equally. That shows our sensor or intelligent parking sensor system is worked well. Now I'm gonna explain about project result for the intelligent parking system for TDP project. In this actual testing, the intelligent parking system was applied in the parking lot at College Kediaman UT Cempaka. The test was performed in 3 empty parking slots and the result was recorded in data collection when the parking slot has been used by the students. So the graph can clearly shows the voltage reading for our project. The graph below illustrates how the signal worked for the parking slots. If any car was parked in slots 1, 2 or 3, the data would display a wave. For example, the value 1 and 2 represent park 1 and park 2 respectively, and the value 3 and park 3 respectively, because the cars only park at value 250 for a short while. The graph is far away and has gaps in it. As we can see at value 278, after that, the wave is close due to a car that has been parked for longer than a few minutes. This graph thus illustrates how long the car parked at the slot. For the next slide, the table below shows the result of the data have been collected throughout the process simulation that has been carried out by our group for the intelligent parking system. As an analyzation, an intelligent parking system using Arduino and Node MCU ASP8266 involves evaluating its component, functionalities, challenges, and the impact of utilizing Arduino technology. For our components, Arduino Uno acts as the brain of the system, managing data processing, sensor readings, and communicating with other components. For our project, we use IR sensors for vehicle detection. These sensors are responsible for detecting presence or absence of vehicles in parking slots. And the LED display provides real-time feedback to drivers by indicating whether a parking space is occupied or available. Node MCU ESP8266 enables the transfer of data from Arduino system to a central server or a user interface. Then for our power supply we use for our project is batteries or external power source to ensure continuous operation for our project.
Assalamualaikum, my name is Muhammad Nazran. So I will explain about the conclusion of intelligent parking system. Assalamualaikum. Next, I will present about the result performance. The performance result of intelligent parking system IPS are critical or assessing in effectiveness in achieving the intended objective and analyzing reduction in vehicle emission and fuel consumption. An urban environment that is more sustainable should result from the successful implementation of IPS. Through a methodology, resumption of the performance metrics interested parties can obtain important understanding regarding the effectiveness and influence of a IPM system. Okay, next is the achievement of all objectives and scope. First, we are able to design the parking appropriately and functionally based on the project goal. Our goal developed our project which we can monitor using Link apps. Next, the project is operating as planned as we had previously said in our scope, which is to ensure the parking lots will no longer require human monitoring as smartphones can do so. Additional data protection measure will be implemented into NotMCU. And lastly, the parking system lets user find and reserve parking space in advance, and it display the available parking space on a LCD. It also provide real-time information on parking available. Next, impact on social, environment, and economy sustainable. Impact on social. First is reduce traffic congestion. Smart parking sensor can help driver find available parking space quickly, reducing the time spent searching for parking. Second is economic saving. The driver can save money on fuel and reduce wear and tear on the vehicle by finding parking spot more efficiently. And the third is smart parking sensor can reduce frustration by guiding the driver to available space. Okay, next is the impact on environmental. First is eliminates the needs for massing parking building and frees up area for park or other types of urban development. Second is smart parking system may make sure that energy is only used when where is required, hence minimizing energy waste. That is help to lower greenhouse gas emission and air pollution. And the fourth is empowering local governments to decide on infrastructure expansion and enhancement to the public transit system. Okay, next is impact on economy sustainable. First is reduce infrastructure cost. Intelligent parking solution can assist in lowering the demand for the kind of substantial infrastructure, saving cities and companies money over the long run. Next is effective resource management. Large parking buildings and unnecessary land use are avoided by using intelligent parking system which maximize the use for available parking space in our country. That is enhance great experience. Business may attract and keep consumer and raise property values in the area of efficiency parking facilities by providing a better parking experience. Fourth is job opportunity. Job in technological development, installation and maintenance can be generated by the development and upkeep of smart parking system. And the lastly is increased economic activities. People are more likely to visit and spend times in commercial area when parking is easier and more convenient, which can help local companies grow and promote the economy. Lastly is recommendation and suggestion for important improve in monitoring system such as build one software or application that all customer and community can download and access. Second is this project is more user-friendly to all community that can monitor from far using smartphone only. And the benefit, it will decrease traffic jam in a certain area that have this intelligent parking system. And lastly, we hopefully, if we get a chance, we can do this improvement, or if have any teams want to do this project, can do this suggestion to improvement this project more valuable. So that's all from our team. Thank you.